Right, hi, this video is meant to help you just get a bit of confidence with trying to do worded questions for surface area and volume. So if we have a look at this, this is from your textbook, question 15 in the reviews. We can clearly see we've got a 3D shape here. Find a feed silo that's made out of steel, 3 millimeters thick, and use a hemisphere, a cylinder, and a cone. So we've got our hemisphere up here. Here's our cylinder. Notice it is only the curved bit. And we've got our cone down here. First thing, explain why the height of the cone is 70 centimeters. So we're looking here at our height. Straight away, sort of going, okay, just take away the measurements. So if we go, the whole length is 3.3, and we take away the 1.8, we think we're on a good wicket here, but we only get 1.5. And go, well, how come that's 1.7? We need to take off the height of our hemisphere. Now that height is going to be its radius. So we'll sort of make it there, like you can see that it's 3D like so. Now I hope you agree that that radius, the height or the radius, it's going to be the same as that distance there, okay? Because we've got our radius. And we can see down here with our cone, okay, that radius, we've got the whole thing is 1.6, which means our radius here has to be 0.8, and the magic happens now when I say 1.5 minus 0.8. That gives me the 0.7, and we're in meters, and we know that that is the same as 70 centimeters. Okay, so that working probably needs to go over here to show you what you've done. You can't just put 70 centimeters because you need to explain why. So little things like possibly saying the radius is 0.8, the total height, right? Height is 3.3, and then you might want to say the height of the cylinder is 1.8. Notice I don't have to write height of cylinder, just abbreviation, and say we can then say, well, therefore, height of the cone is going to be 3.3 take, and so on. Okay, so hopefully that makes sense to you there. All right, the next one. Hence, find the slant height of the conical section. Now let's say that you didn't actually work out this. You couldn't figure out why it was. It doesn't mean the whole question is gone. It means you can use this to still do part B. So we know that this height, or they've told us that this height here, right, that one is the 0.7. Now I'm going to draw the diagram out so it's not messy over there. I know that this is 0.7. We want the slant height, and means that we should know this length here. And of course, we had figured that out. That was the radius, which is 0.8. So now it's up to our friend, your friend and mine, Pythagoras, to find S. Remember, I like you to write the rule. So a squared plus b squared equals c squared, and then we pop in the values that we have. The a and the b are your two lengths that make up your right angle. Happy days. We don't want s squared. How do we get rid of the squared? Square root. Okay, so oops, why didn't I square that? So pop that in your calculator, and that will give you your answer. Okay, right, that's what we get when we put it in the calculator. If I want 2 decimal places, so we have to look at the 2 decimals here, and make sure you look at the third one. Because this number is less than 5, then we say 1.06 meters. Okay, excellent. Okay, onward and upward. Calculate the total amount of steel used. Now, you have to make a decision. Are we talking surface area or volume here? I hope you agree with me. We're going surface area because we want to make this out of the steel, and so we're sort of wrapping, you're wrapping it / painting it, that surface area. If you were to fill it, if we look at part D, show that the silo can hold 5.2 cubic meters. So as soon as it says the cubic meters, that's when we know that we're talking volume for D. So it's surface area for C, volume for D. What you should immediately do is go to your formula sheet, and you have your formulas there. Okay, now we look and we've got half a sphere. I like to put my little diagram so I can see very clearly what we're doing and put the information that you need. So we look at our formulas, and for the surface area of a sphere, it's 4 pi r squared, but we want half. So I'm going to divide that by 2. You smarty pants out there that say, okay, 4 divided by 2 is 2, and you can just write 2 pi r squared, feel free. Okay. And do we know the radius? Yes, it's 0.8. What about our cylinder? Okay, this part here. If I look up the formula for surface area there, let's go and have a look. Look at the cylinder, not the cone. There's a big tip, get the right one. This gives you the curved bit. This is the top and the bottom. Clearly, we only want the curved bit, the 2 pi r h, otherwise the grain wouldn't be able to go all the way through. So we're going to say plus 2 pi r h, okay? No top, no bottom. So do we know the radius is the same all the way through, so 0.8, and what is the height of our cylinder? It's 1.8, okay? If you have all that information there, it's really easy then to just pop it in. It becomes a calculator job. Go back, we want the surface area of a cone. Once again, we look over there, and it's got 2 parts to it. The pi r squared is the bottom, so let's not include that. We're just going to have pi rs. So we've got pi rs. We know that r is 0.8, and we know that s, we just worked out before, is 1.06. Another important tip is, let's say again you could not work out the slant height, something went wrong, and by the way, do we know that this is right? Yes, it's bigger than the 0.8 there. So let's say you couldn't get that, it didn't make sense, make up a value so you can show me that you can still do this next part. Don't ever leave it blank. So we just now, so 4 divided by 2 is 2, but you could just pop everything as you see in the calculator. So your radius is 0.8. Don't forget to square it. It says plus, I put plus. It says 2, I'm putting the 2 times pi. I can hear some of you saying, do I have to write all of this? Yes, please. Okay, it just helps me give you marks, because that's what I want to do as I'm marking your test, give you marks. The radius is 0.8 and your slant height is 1.06. So you just have to pop all of that into your calculator, and the only thing you have to remember is to make sure that you put your units squared at the end. Okay, we should have got 15.73. The last bit, show that the silo can hold 5.2 cubic meters. As we said, that is volume. So just like we did with surface area, go back, look at your formulas, and now instead of looking at the surface area ones, go and find the volume. Okay, so look at your volume formula. That's the one that we're going to put for the sphere, is 4/3 pi r cubed, but remember that's for a whole cylinder, a whole sphere, and we only want half. So you can divide by 2, let your calculator do all the work. Again, you could have just written 2/3 over pi r cubed, plus the volume of a cylinder, pi r squared times height. If that's not easily reachable on your formulas, then please change that. And with the cone, oops, wrong one. With the cone, it's sort of a little bit hidden there, but area of the base, now that's pi r squared. So you might want to add to your formula that volume of a cone is 1/3 pi r squared times height. Okay, so back over here, plus 1/3 pi r squared times height. And I think I can leave that there because you are quite capable of now popping in all of your information, except, oops, do we have the height of the cone? You can't use the S. You have to go back, right? The height we had established was 0.7, which was at the start of the question. And again, if you had not got that out, make it up so you can at least get marks, okay? Because as I'm going through, when I'm giving you the marks, even if you pop your formulas down, I'm going to go, yep, that's a mark there. You're showing me that you can pop information and use your calculator. Absolutely. Okay, and you've got the right units, so that's good there. So if you just, get some of these measurements wrong, that's unfortunate. but you won't lose all of your marks. So the key is attempt every single question. All right, good luck. Hope that helps.